So welcome everyone to our actor sting session. Could everyone please go on mute who's online? Let's see, there's a little feedback coming through. My name's Andrew Forbes. I'm co-chair of Actor Sting with Kate Lee, and it's my pleasure to be hosting this session. I'd like to begin by acknowledging the traditional custodians of the lands on which we're all meeting. For me, it's the Bunurong people of the Kulin Nations, and pay respect to elders of the lands which all of you are located as well, past and present. So it's my pleasure today to be hosting this session on the wonders of GitHub. And it's going to be presented by Dr. Hannah Johns, who's a research fellow in the Melbourne Medical School. Research interests include the development of improved randomization methods and novel approaches for the analysis of complex and multifaceted outcome data. Now, she is an absolute guru of programming, has contributed quite a lot to CRAN, so the R archive, and is an expert on GitHub. So I'm very excited that she agreed to present on GitHub. She actually volunteered to run this session when we called for sort of expressions of interest. And I'm sure all of you who are not familiar with GitHub will come away from this being amazed by the version control facilities that are available. So I'll hand over to Hannah in just a moment. But I just want to say that this will be hopefully this will be an interactive session. So please put questions in chat and I'll be monitoring those, and Hannah's also going to stop periodically and ask about questions too. So now that that's done, I'll hand over to you, Hannah, to share your slides so we can get going.
Thanks a lot. Let me just find the share screen button. There it is. Okay, thanks a lot. So, yeah. Okay, so
I'm just sitting in my computer.
Are we all good? Okay, I think we're all good. So as this webinar is going to be largely two parts. First off, just a bit of background about what Git is and why you should be considering using it. And then, as Andrew said, there's going to be some live demonstrations of what Git looks like in practice. As a general note in terms of the tone and structure of this, it's meant to be fairly light and reasonably non-technical. There will be some tutorial elements. Feel free to follow along if you can. The third section does require a buddy, so it may be more practical to do this after practice with someone after we've wrapped up. But this isn't required. The webinar is being recorded and these slides are going to be provided as a resource if anyone wants them as well. So the way that people normally talk about Git and GitHub is not what we're going to be doing today. So in Biostats, we produce an awful lot of code. This takes the form of software when we've developed new methods that improve on current practice. It takes the form of simulations that we run for looking at methodological research as well as for trial planning. And of course, when we run data analysis, we produce code for that as well. And that covers everything from data cleaning through the actual analysis, through any post-processing and formatting we need to do to prepare things for presentations and for papers and so on and so forth. Now, in theory, and ideally, all of the stuff that we're doing should be pre-specified, but that's not often necessarily the case. So what you can have is, and based on an entirely fictional story that's not based on true events whatsoever, you can have a situation like as follows. Imagine you've got a big project of about 3,000 lines of code for a very large and complex project you're working on. And after you've gotten all this into a reasonable shape, you get an email from one of your collaborators. Oh, I forgot to tell you to exclude observations with ABC from that analysis. Can you fix that? Okay, that's not too hard. It's typically a couple of lines of code to exclude some people from analysis, so you do that. Then you get another email. Oh, yeah, I wasn't quite clear about how I should define the subgroups. Can we please do it this way instead? Yeah, that's my bad. I should have been clearer. Sorry. That's fine. You go and fix that. The column wasn't clean. Can you also merge in data from this sheet instead of the one that I gave you originally? Oh, and then eventually the paper gets rejected. Can we rework the analysis before we submit it elsewhere? And you do all of that. And then they ask to re-add those people with ABC back in. And then just when you think everything's done, can we reuse the original methods again? So at this point in this hypothetical situation, you may be starting to be dealing with resisting the urge to throw something heavy at the person sending you these emails. The other thing that you may be thinking of here is that Murphy's Law is ironclad in this business. And it is especially ironclad when you're dealing with writing code. Something that everyone that is in this industry is very aware of is that you can lose data all the time through data corruption, your PC dying, whatever. And as a result of that, often we are all very good at keeping backups of anything that we need access to in case our machine just dies on us. But that's not the only thing that can go wrong. As indicated in the previous slide, we can have version control hell where things are changing constantly and we're constantly having to keep track of what's going on. And for that, we really need a proper version control system, including a way of documenting and creating a history of any changes that have been made. We can also have too many cooks in the statistical kitchen. Especially in large projects, if there are multiple statisticians involved, it can be unclear about who is doing what, and also who is doing what can change over time as the project evolves. So we need some way of sensibly managing that collaboration and tracking who has done what and who is doing what. And then finally, coming back to the original point from before, that when we produce new methods, we want people to use them. People will not use them unless we provide them with tools for actually using whatever we've developed. And so we need some place that they can download tools that we've developed for the use of new methods from. We all have some solution to these problems. Often it will be a mix of OneDrive or Dropbox or sending things via email, but this only does so much, and it's a little bit of an ad hoc way of going about doing this. So this is why Git exists. So Git solves all of these problems. It's in the class of software called version control software. And basically what that means is it provides a fairly rigorous way of handling all of these things. The way that Git works in particular is it represents the evolution of code over time in terms of an acyclic graph without going too much into the nuts and bolts of it. Basically, every single snapshot or commit in Git's language is a node in this graph. And then over time, as you make changes to your code, that is new nodes in this graph. You can have branching versions of this where the code can develop in different ways. We'll cover that in a minute. And then on top of that, if you wanted to go back and revisit what the code looked like at a previous point, you can just go back and revisit one of these nodes. Git is an open source software. There's multiple different services that allow you to use it online. The two biggest ones of these are GitHub, which is owned by Microsoft, which is the one that we're using today. But also there are others. Another one is Bitbucket, which is run by Atlassian, and there are others as well. If you really want to go super enthusiastic about this, you can host your own Git repository server for doing this stuff as well. I wouldn't recommend it. These services are more than sufficient for most people. The way that Git works behind the scenes is actually not too different in terms of a practical situation to, say, for example, OneDrive and Dropbox. If you think about the way that OneDrive and Dropbox and these files syncing services work, there are three components to it. Number one, you've got the online cloud version of whatever the files are. You have some client which you will download and install on your machine and then promptly forget about because it just runs automatically in the background. And then you've got whatever software you're using to write code in. That can be RStudio, it can be Stata, it can be any text editor, any file editor in general is what you use there. And the way that these systems work is that the client will track any changes that you've made in your local files, and it will upload them to Dropbox or OneDrive or whatever online. Likewise, if it detects there's something that's changed online that's not reflected in your local versions of the files, it will download those changes and make those changes to your files. Git works more or less the same way, except the big difference here is that at every step, it's an explicit thing you do and you have much more control over what's going on. There's a whole bunch of jargon attached to all of these different steps. So pushing, pulling, cloning, we will explain what all of these are as we go through and demonstrate this. But here's a snapshot of some of the language that we'll be using later on. Now, when people do normally learn how to use Git, the way it's done properly is via command line. And this typically requires you to have some familiarity with Linux, is the system that's normally taught in. We're not doing this at all today. Instead, but if you did want any of this, there are a bunch of resources online. Here are some resources that are quite good that explain how to use Git properly, quote unquote. Instead, what we're doing is we are going to be using a couple of point and click interface for doing all of the interfacing with Git. Specifically, we're going to be using GitHub Desktop, but if you didn't want to use that, there are plenty of other options available. That second link on this slide will go to a page which provides an overview of some of the free and paid ones. On top of that, some different coding environments have Git integrated into them. Some big examples of this are RStudio, PyCharm for Python, and then VS Code as well. Ultimately, it really doesn't matter what you use for this. If you wanted to go nuts and use the command line, you can also use the command line here. Just use whatever you find to be the most convenient and easiest for you. Today, we're going to be using GitHub because GitHub is a reasonable option to use here. So that's the end of the background. The rest of the seminar is going to be focusing on 3 different demonstrations. So the first of these demonstrations is going to be just some very rudimentary introduction to how to use GitHub as the first thing. Then once we've gone through that, we're going to be talking about using branches. I'll explain what that is in a bit. And then finally, we're going to be talking about working with other people for collaborative projects. Just a couple of notes about this. This slide pack does contain a whole bunch of screenshots of these steps. This is largely just here as a resource for later if you wanted to refer back to these slides. We're going to be skipping over these because we're going to be demonstrating this live. If you have a GitHub account and GitHub Desktop installed, please try and follow along if you want, if you feel comfortable with it. If not, that's totally fine. So with that said, let's dive in. So the first demonstration is going to be talking about working with repositories. So repositories in GitHub's language or Git's language is just what they call a code base or project that all of your work will sit within. And so I'm going to I'm going to quit out of this presentation for a second to show you github.com. Can we see GitHub? Okay. So the first thing we need to do is we need to create a new project. And the way we do that is we click on new. Depending on how many projects, if this is a completely blank GitHub thing, it may be called something different. It might be called create repository. It looks something like this. It has the little book logo and it's green. When you click that, it will take you to a wizard. We then complete this wizard. We need to give the repository a name. I'm going to call it demo repository. And then we need to give it a description. So I'm just going to give it, this is a description, a demonstration repository for Actisting. Once we've done that, we need to specify if this is going to be a public or private repository. Generally speaking, if you're wanting to do this for work stuff, it will typically, you'll start with private, and then if it's public, you can make it public for people to look at later on. For now, we're going to make this public. Generally speaking, you'll want to provide have a README file, so that's good to check that box. This is the README file is where you provide a summary of what your repository is for, what it should contain, and so on and so forth. Then you've got this line here about adding a git ignore. We're going to skip over this for the time being, but I will talk about this more at the end of the seminar. And then if you wanted to choose a license, these are usually just like various public copyleft like GPL type licenses that let other people use your stuff for open source. We're not going to bother with that for the time being, and we're just going to leave that as none. And then once you're happy with all of this, you just click create repository. And once that is done, it will produce a new repository for you that is currently empty, except for this README file that we told it to create, which just says it's called demo repository, and the description is this is a demonstration repository for Actisting. So in order to actually use this, we now need to download all of this into our local machine. The way we do this is we click on code up here, and there will be a bunch of different options. There's just a little button here, open with GitHub Desktop. And if we click on that, it will open up GitHub Desktop for us, assuming that we've got it. It then autofills that URL for whatever the repository is. And then we specify a path where we want to put it. So I'm going to put it in webinar examples, select folder. And now when I click clone, it will download it. And what I will see is I will have on my local machine, if I minimize out of this and go to webinar examples, demo repository, I have a version of this repository on my local machine now. I can see this readme.md file, which is that file that we had created before. If I click on edit with Notepad++, it will open up here, and this contains that file that we had there. So with that said, now we can start to input some code into this. So this is where all of your code for a particular project would live. So once we've done, we need to create a file which contains some code. I'm just going to do this using in a text document, so some code.txt. This would be in practice a R script or a do file in Stata or any other form of code that you would be writing. I'm just going to open this up in Notepad. In practice, you would do this using whatever you write code in. And I'm just going to say this is some code for the demonstration. Save that. And now that I've saved that, it's in the folder containing the repository. And if I go back to GitHub Desktop, I can see here under changes, this file is now being tracked here. It's saying that we've created this here. So now we've got that. The next step is going to be to save this and upload this. So the way we do this is we need to create a commit, which is effectively just a snapshot of our repository as it exists at a particular point in time. So it's added here. We need to give a name for what we want our commit or snapshot to be. So I'm just going to say this is a commit. And then commits a saved snapshot of our code. And once I've done that, I just click commit to main. Once that's done, that will have saved the snapshot, but only on our local machine. We now need to get that back up into GitHub on our remote version of it. And so what we do is we just click push origin. Push origin is effectively just upload, is effectively what it means. So if we click push origin here, it's doing a thing. And then once that's done, that's done. If we go back to looking at the repository, if we refresh the page, what we have is now some code is uploaded there. And you'll see this is a commit, was that name, the title of that commit that we went to. And if we go and click on it, you can see it's got the code that we specified in there. So with that done, the next step with all of this is to demonstrate how we can use this to recover things that we've lost on our local machine. So I'm going to go into the demo repository and I'm just going to delete it. I'm just going to click delete and wipe the whole thing. Now, if I go to GitHub Desktop, it'll say that it can't find that demo repository, and it'll have three options. One, remove the link from GitHub Desktop, but I got rid of it. Two, locate. Basically, I moved it somewhere else. I need to tell GitHub Desktop where I put it. And the middle one, which is what we're going to go here, clone again, is basically saying clone just means download. Download the most recent version from github.com for that. So if I go and click on that, now when I go into here, demo repository is back. I go into there, some code.txt. It's recovered back from what we put up in github.com. So the important thing to note with this is that this will only recover things that you have pushed to the to github.com. Any changes that you've committed on your local machine but haven't pushed, you would lose in this particular thing because we're downloading a fresh copy from GitHub. So with that done, let's show how we can make some changes to code. So let's say we had made some more changes to our code base. We had done some more stuff. This is some more code. that we have changed. Let's save that again. And now when we go back into GitHub Desktop, it'll show you what has changed in terms of how the code has changed. And so we can do the exact same thing. I'm going to say second commit. This is another commit. We then commit to main, and that saved the snapshot. We then push to upload again. And once we've done that, we can then go and revisit this in GitHub. What have I done wrong? Sorry, I closed the page like a silly person, demo repository. So now you can see it says second commit. If we go and look at what that file says, you can see there's some more code that we've changed. So the changes that we've made have been uploaded. Now, so up until now, this is more or less what you can do with OneDrive and Dropbox and so on and so forth. What we can now do with all of this, though, is if we want to go and look at the history of all of the files, we can absolutely do that. So if we go into what's the easiest way to do this? The easiest way to do this is in GitHub Desktop. If we go to history, you'll see there is a list of all of the changes that we've made to all files over time. So the initial commit is when we created the repository. Then we had the time that we created some code.txt. That's what little plus there means. And then we've added that code to it. Then second commit, you've got the orange here. The orange means we have edited that file, and you can see we have added that second line. And if we wanted to go and revisit what this code looks like at some other point, what we can just do is we can just right-click on any of these previous forms and go check out commit. It will then warn you about if you really want to do this. You can just click checkout and that will be fine. Once that's done, if we go and look at what that repository says here, if we open up some code, it has the previous version of that file now showing for us. So we can go and revisit any file that we've saved in GitHub at any particular point in time that we've saved it. To return back to the main version of it, we just need to click on this middle tab here. This is for just navigating branches, which we'll talk about more later on. And just click on main. Once that's done, we can then open up some code.txt again, and we're back to the version containing everything that we are up to. So some general tips for doing all of this. Never, ever, under any circumstances, place a Git repository inside OneDrive or Dropbox. Have it as all of these in a separate folder. Likewise, never place a Git repository inside a Git repository. Terrible things happen when you mix file syncing systems. Just don't do it. It's very easy to get into the habit with all of this as well of getting lazy with commit messages. But try to avoid the habit as much as possible. If you have to revisit your code in a couple of years' time, you will have forgotten everything you've done. And often the only way to really recover from any of this is based on whatever you set is those commit messages as a prompt for reminding you about why you made the changes that you did. Another general note that's always good here is if you're planning on writing code that other people are going to be using, it's a good idea to get into the habit of using semantic versioning numbers, which is basically you describe a piece of code that you've written as major.minor.patch, for example, 1.12.103. Major versions corresponds to if you have changed something that will fundamentally break how other people use the particular thing you've built. This is, for example, doing a complete rewrite of how everything works to make it more streamlined or more efficient. Minor patches correspond to things that are feature additions and stuff like that that don't break anything. It just adds new features. And then patches are bug fixes and so on and so forth. This is probably a good point to stop if anyone had any questions.
Oh, Hannah, I'll just ask, like your little cartoon there. Do you find that's the case, that you're very enthusiastic with all the commit messages?
Yes, 100%. I would show you the history of my Git commit. I saved my PhD thesis because I was doing it in LaTeX in Git as I was doing it, and I would share with you over this while all of the stuff that I had put in those messages, because it would be a great demonstration of this particular point. The problem is it's not appropriate for this particular context. There are too many curse words in it. Try to avoid that. Everyone does it, but it's best to avoid it where possible. But this is absolutely the norm. It's a bad habit everyone has. Okay, so with that, let's move on to the next step of this. So what we've just described is fairly sufficient for if you're working on small projects that you're just doing for yourself, but it's not really suitable for if you have larger projects or where the code always has to be in working order. For example, if you have written some software that other people are using, that they need to have access to the working version of it, the last thing you want to do is break the code as you're trying to upgrade it. And so when you're doing this sort of work, this is where branches come in. So coming back to the idea of viewing changes in code over time as being part of this graph, imagine here we've got a repository that's had 2 commits. So there's 2 versions of it. And then we're interested in developing a new feature. And the way that we do that, if we want to be sensible about this, is we produce what's called a branch. I will describe how to do that in a second. And over in this development branch is where we're making any changes for the upgrade. Imagine as we're doing this though, someone finds a bug in the code that exists, and that needs to be fixed urgently because people need to use the code and we need to fix the bug. So what you can then do is in the main branch that you're working with, you can make the urgent bug fix to fix whatever the issue was, and then people can download and use that particular version of the code while you're still doing all of your development stuff here without having to worry about that bug fix. You then continue with the development of your new feature. And then once that's ready to be published with the rest of the code, you then merge these 2 branches together into a single version of the code. So this is the idea of working with branches, and that takes us to this next demonstration. So I'm going to, again, quit out of doing that share. So the way that we can do this is we will go into GitHub Desktop again. And what we will do is we'll click this middle column here, which is select branch. And then what we do is we'll click new branch. Once we've done that, it'll ask us to create a name for the branch. I'm going to call this something like development branch. You can call it whatever, call it something which is sensible. Then we click create branch. And once we've done that, if we click on this middle column, you'll see there are 2 options here to select from, either main or development branch. By clicking on main, it will take us to the main version. By clicking on development branch, it'll take us to the development version. So we're on development branch right now, which is why it's got the check. So that's what we're going to stay on. This is the technical term for doing this swapping between things is called a checkout, checking out another version of the code. It's what we were doing before. It's just more of this Git terminology for describing everything. So now that we've got this new branch created, what we're going to do is we are going to go into our code here. We're going to open this up here and we're going to add a new feature. So this is a new feature that we are developing. We save that. And then we will go back to GitHub Desktop as before. You'll see that the change has been made there. We do the exact same thing we did before. So we give a commit message. We say, this is a development feature. This is a new development feature. I can't type. Then we click commit to development branch. And so you can see that's different there because we're doing it on development branch. And then it'll ask us to publish the branch. This is effectively just the same thing as push as before. You click that. Once we've done that, it will push it to github.com as before. We will talk about pull requests in a minute. But if we go to the repository on github.com, we will see now that there are 2 different branches. So we've got the development branch and we've got main. As before, if we see here on some code.txt, it doesn't reflect that change. If we change this branch to development branch and then look at it, you'll see that's where the change has been stored. So we've got two versions of the code as it currently exists in the repository. So now that we've done that, we've made the change here. Let's say the situation that we were talking about before happened where there was a bug fix that needed to happen. So what we would do is we would go back to main. If we go now look at some code, that development line that we put in isn't there anymore. Let's say that we add now, this is a bug fix. Something like this. Let's just put it down here. Save that. You can see where that change has happened there. I'm just going to say bug fix and bug fix as before. Commit to main, push origin. And now that we've done that, we've got two different versions of that code. One has that bug fix that we've done. The other, if we go and look at it, doesn't have the bug fix, but has the new feature that we added. So let's say we have continued on with this, and now we're happy with what this feature looks like, and we're ready to combine it with the rest of the code. So what we can do, I'll show you, there are many different ways to do this, but basically what we're going to do is what's called a pull request. A pull request is also called a merge request. It's the process of taking two of those versions of the code and merging them into a single version. You can do it here. The way I'm going to show you is via GitHub online. If we go to branches, you've got main, you've got the development branch. What we can do is we can click on here, the three dots, and go new pull request. When we do that, it will ask us to describe whatever, if we wanted to specify in terms of what we've changed. So pull request for a new feature, something like that. And then we can just click create pull request. Once we've done that, it will try and do it. And what it will see where it said checking for changes for being able to merge. It's saying it has conflicts and must be resolved. This has happened because we have changed that code file in both versions of the project, and it doesn't really know what to do anymore with that. So what we need to do is we need to click on resolve conflicts in order to fix this. So you can see here, it opens up a text editor for you to have a look at the code. It highlights what the code looks like in the development branch versus what it looks like in the main branch. And it will ask you to manually tell it what it wants to do. So what we can do is we want these two lines here because they are common in both. And then we've got, this is a new feature that we're developing. We wanted that. And then we also wanted to include that bug fix from the previous version. We can then get rid of anything that was left over in all of the clashes. And then once we've done that, we can click mark as resolved. And now it's happy. We can now commit merge, which is create a snapshot with that merge done.
Oh,
and once
Hannah?
that's, yep.
Yeah, sorry, just a question for myself here. We've got a few questions in chat we'll come to towards later, but is there a record of these changes that you've made manually here in this merge?
That's a fantastic question. Yes, so you'll be able to see that in a second. I'll show you what that looks like. So if we go, so we'll merge that pull request, confirm merge, and that's done there. What we can now do is, so that's pull request successfully merged and closed. If we're done with that extra development branch, we can just click delete branch and it's gone. It no longer exists. We don't need to worry about it anymore. So going back to that demo repository, what we will see if we look in the, actually, okay, before we go into that, let's go back to GitHub desktop and go back to main. What we need to do now is we've made changes using the GitHub online tool that are not reflected currently on our local machine. So what we need to do is we need to click fetch. Fetch will just fetch any changes in the thing and is basically the precursor to syncing. Once we've done that, we can then pull origin. Pull just means download, much like push means upload. So we pull origin. And once that's done, if we look in the history, going back to the change here, you can see here the changes that we've made for that merge happen here. So you've got all of these here. You've now got the development feature was added there and the bug fix was added there. You've then got the changes where it's all been combined there. And then you've got the case where it's all been combined there. So to answer the question that, that Andrew had, yeah, all of this is tracked there for you. So with that, so that's how you can merge everything together. And then what we can do if we go and look at the local version of that file, you can see we've got both that bug fix and the new feature that we've added to the code there. So some more general tips with all of this. It's generally speaking a good idea to make sure that you sync, that you fetch and then pull before making any changes to your code, even if you're only working with one branch. This is really important if you're working with multiple people, if you're working across multiple different machines. It will make sure that you keep up to date with any changes that happen. With that said, errors do occur. And in practice, the strategy that was jokingly proposed by XKCD of just saving your changes elsewhere, deleting everything and then re-downloading it and then adding your changes back in will, in practice, solve most of your problems. It's not good practice, but it works and it works reliably. So it's the way that most people end up doing this sort of stuff. A final bit of advice for trying to avoid these conflicts is to try and separate your code into multiple files where possible. So, i.e., have a separate subscript for doing your data cleaning, to doing your analysis, to doing your presentation work, and then just call all of these in a big global script that will just have a bunch of source or do statements, depending on if you're using R or Stata. And that will fix all of the, that will help minimize the chance of having these merge errors. This is a good point to stop to answer those questions as well.
Okay. Now there was one question about when you're working with multiple people. So I'll hold that until you've covered that section. Someone asked, would it matter if you edited changes midway through, right? Like using R and then Notepad?
Okay. So not really, in that any changes that you make before, okay, so if you were to make a bunch of changes and then not do this commit, push, etc., it would not see and then make more changes. It would only make the snapshot or the commit when you do that commit and push and so on and so forth. If you were to make a bunch of changes, to make the commit and then make a bunch of changes, I'm pretty sure the way that that handles that is it will upload the snapshot, but you will still have more local changes that will be sitting on your disk. It's not a huge deal to do that. In general, you usually want to make the commit and then push the changes that you've made almost one immediately after the other. You just, as I was doing here, click and then click. But I don't think it's a problem.
Okay, I've got a couple of other questions. May as well go through some of those. Oh, this is an interesting one.
Oh, sorry. Sorry. I misunderstood it. Would it matter if you change if your editor changes? So, i.e.,
if your editor, yes.
Oh, yes. If your editor changed, it literally doesn't matter. Because so GitHub and Git, it just reads the files on disk. Whether you're using Notepad or RStudio or Stata, it literally doesn't matter. It's just looking for those local changes.
Okay, another question about interesting. So you're talking about code base, but the question is, can you also commit the output produced by, say, R?
Absolutely. You can absolutely do that. It won't. The only difference is that when you go and look at the particular files online, it won't be particularly pretty to look at. So, as an example of this, let me show you what it looks like. So, let me open up Paint, and let's just take a screenshot let's just draw a little hi with a like smiley face. And then we're going to save this. And we're going to save this into the repository. But where is it? Is webinar examples, demo repository, untitled.png. That will do. Now, if we see the changes, we'll see the file there. If we go and just say picture with a smiley face, commit to main, push origin. If we then refresh this, untitled.png, it will show there. So it's not just plain text. Any files that you want will show here. However, if we were to make changes to this particular picture here, it wouldn't be able to show you exactly what has changed like you've seen with all of the plain text. Because it's not a plain text file, and it's not, while it supports it, it doesn't support all the same features it does for plain text.
Yeah, so Hannah, sorry, hi, this was question from me. I wanted to understand, the program that we are writing, let's say we are writing in SAS, and then we generate a data set using that program. So when we commit the program, the output is automatically like saved, a version is saved, or we need to do that separately?
Okay, so any file, so you need to manually tell it to make the commit and then push. So this is the difference between using GitHub and Git versus using OneDrive, for example. Where OneDrive does all of this automatically, you need to push some buttons here and tell it what you've done. So that's the only extra step.
Okay, thank you.
Hannah, we've still got quite a number of questions, and I think in hindsight we should have had a version 1 and version 2 with version control of this. Just wondering if you haven't got to sort of collaborative work.
That's literally the next bit. So
yes, that's right. And then we'll I'll defer the questions until after you've done that, and then we'll try and get through those. Yeah, thanks.
Okay, so the next part of this is collaborating with others. So this is one of the things that Git is really, really good for. And this can be done in one of two ways. The first way is either just with private projects where only you and members of your team, for example, that you've shared your code with, can see it and make change and suggest changes and so on and so forth. But then on top of that, you can also do this in public. And in that setting, anyone can see your code, make suggestions, and so on and so forth. Most open source software is shared this way via GitHub or a service like it. And most R packages are available on GitHub in this particular way as well. So here's a screenshot that I've taken from the ggplot2 repository on Git. On GitHub, while we like to think of this as being something which is written entirely by Hadley Wickham, there's actually been about 300 different people that have contributed code to this package and have made it what it is today. So this takes us to the final of these 3 demonstrations, which is working with others. So as I think I said at the start, you do need a friend for this last demonstration. If you don't have any of those, a second GitHub account and another computer will do. And so with that in mind, let me show a second GitHub account with a virtual machine that I set up before. So what you'll want to do with this is you're going to want to navigate to the code that someone else has written that you have access to. So I'm just going to go to why is it of all the times for it to, there we go. It was just being a bit slow. So there's a reason why I made that repository at the start public, and it's so we could do this. So I'm going to go to demo repository. And what we can see here is that version of the code that we were working with before. I'm just viewing this because on this user account, I don't have access to any of the code. So if I want to make some changes or suggest some changes to this, what I need to do is I need to click here where it says fork. Fork is basically just the GitHub jargon for saying create a new copy of whatever you're looking at. So we're going to do this. It's going to ask me to fill in all of the same stuff that we had when we're creating a repository to start with. I'm just going to leave all of that as is. I'm only going to copy the main branch because that's the main branch that we're going to suggest code going to. And then we click create fork. Once that's done, we can then do exactly the same process that we did before, where we go to code. We then would ideally click the button here saying clone using GitHub Desktop. I don't have it set up on this machine. So what I'm going to do is I'm just going to copy this URL. And then once I've done that, I go to GitHub Desktop, clone a repository from the internet, then just grab the URL, paste it into here. It will then create the repository locally. And now that this is done, okay, it'll then ask us if we want to, if we're doing this just because we've decided to make our own version, we're going to do our own thing, then we just click for my own purposes. If we're planning on like sending code back, contribute to the parent project is what we click there and continue. To open up the files on our local machine, I'm just going to go repository, show in your file manager. It will open it up. And I can see here that smiley face that we made before. I can see some code.txt. And what I'm going to do here is I'm going to say, write some more code. This is some code suggested by another user. Save that. Actually, hang on, I've missed an important step here. We're not going to do this first. The first thing that we should be doing before doing any of this is we should be in our local machine creating a new branch. We should always be trying to make a new branch before we make any changes to push back. It saves headaches in the long run, and it means that if any changes have happened on the main repository, it's easy to get synced up with whatever's changed there. So it solves the problems of bug fixes and so on and so forth, as described before. So new branch, development branch as before, create branch. Bring my changes to development branch. That will do. You shouldn't see that. That's just because I messed up and forgot to make the branch. So what we can now do, well, now we've moved to this demo branch. This is some changes to the code suggested by someone else. Save that. And now once we've done that, we can do the exact same process that we had before, where we can go to we can go and commit this, some changes, commit to development branch, publish branch. You've seen all of this before. And where things are going to be different now is if we go and view our own version of this repository on our local machine, on this account, we will see here, once it has loaded in, there are two branches. If we go to branches, what we can do is we can click on our branch here, new pull request. And what we will see is you'll see here, rather than merging into two of our own versions of this, we are going to be, we're going to merge from Hannah demonstration, which is this user here, to Hannah Johns, which is the version we've been using up until now. You can see the usernames here are different. So some changes and changes. Click allow edits by maintainers is usually a good thing. Let them suggest edits to the code you've suggested. Create pull request. And then once we've done this, it's checking for ability to merge. And because we didn't have that issue with the files being edited simultaneously, we don't have any problems there. And now what we can see here is that's grayed out. We can't, we don't have any ability to actually make any of these changes ourselves. We've just suggested them for the owner of the repository. If we wanted to make any comments or like talk with the owner of the repository, there we can write some stuff here. So hello comment. That's now been posted here, so you can chat with whoever is the owner of the repository there. Going back to the owner of the main repository, what we will see here now is up in this tab here, it says pull request, and it's got the little one next to it. And what we can see is by Hannah demonstration, that other user, we can see the suggested change there. There'll be ideally some documentation here about what they've changed and why. We can go and view whatever the change was. So you can see that's where the change is. And if we're happy with that, then we can just go and merge the pull request. If we're not happy with that, we can say, no, I don't like that, and close the pull request. Or you can ask them to change some things and so on and so forth. So we're happy with that. We're going to click confirm and merge. And that will work exactly the same way as all of the branch merging that we discussed before did. So now if we go back into our local version of this, fetch, we then pull, and this will repeat the same process that we had before. We open up that repository. If we go to some code, you see here's some changes to the code that was suggested by someone else. So with that done, that's all the stuff we're talking about here. Some final general tips for all of this. As discussed before, best practice to try and make a new branch after you've made a fork, just to keep any changes that you've made contained. It will minimize sync issues later on if you do that. If for whatever reason you also fall behind the main repository, this is another reason why it's good. You can just click, there's a little button in GitHub where it'll say you're behind, where you can just click sync. It will automatically sync with any changes that have been made by the main repository, which means that you'll get bug fixes and so on and so forth in your version as well. It's extra important if you're working with others to document exactly what you've changed when working with other people. As an example of this, serendipitously, here's some screenshots of a pull request I received last week for some code which I've written. This person here very sensibly realized I had hard-coded a graph to have a fill legend saying MRS, and they've changed it to be a variable that allows a user to supply whatever label it should be. So they've caught a bug. They have made a change to say what that bug was and what has changed. And so I haven't pushed the button yet, but I need to push the button because they have fixed a problem in some of my code that I've published for people to use. So to summarize, what we've covered today is a whole bunch of different rudimentary stuff for using Git, including how to download repositories or clone them, create snapshots or commit, push and pull, which are upload and download respectively, forks, which are to make your own copy that you can make your own changes on, and then pull requests, which is how you can merge different versions of the code together. But it's important to note here that we've really just scratched the surface of what Git can do. We've not covered the use of git ignore files. Basically, these are files which will these are files which will tell Git to ignore the existence of certain documents and files. This can be things like sensitive data, other things you don't want to be in the repository. The .r history file is a really good example of this because it's just garbage that doesn't need to exist for the repository. Other things which are useful to know about are issues, which is GitHub's feature suite for documenting bugs, feature requests, and so on and so forth. Releases, which is a way of producing somewhere you can download versions of the software for other people to use, as well as wikis. All GitHub repositories have their own wiki attached to them where you can extensively document everything you care about. There's lots more than this, but try not to feel intimidated by it. The fact of the matter is that most people that use Git don't really understand how to use Git properly, and that doesn't stop anyone. Just learn as much as you need it, and you can use this to really help organize a whole bunch of your work. With that, thanks so much for your time. Again, here were those resources that I linked at the start of the presentation.
Thank you so much, Hannah. That was wonderful. A bit of a whirlwind tour. I'm a little bit dizzy from watching your cursor flying about the page. Now we've got quite a number of questions. We're not going to have time to get anywhere near through them. Are you willing, if I was to supply you with the questions to just in a text document with version control to be able to
absolutely
provide some responses there, and then we'll post the sort of the questions and answers on the Stegan website next to where we put the recording for this session. I think that's probably the best way to go. There was only one question that required a demonstration. It was just sort of backtracking a bit, whether you could do a quick demo of someone. I don't know if I can find the question exactly. It was about a quick demo, how to recover code deleted when you've committed a few lines of code, then delete them in the next version, recommit the version, and then you want to
Yep.
get the original code back. So this is something that we're all going to be doing thousands of times, I
Yep.
would imagine.
Absolutely. I can show you how to do that now. It's very easy. Okay, so what I'm going to do is I'm going to, in here, I'm just going to delete some code, which is our entire code base. Say, now we go into here. You can see it's, we've deleted that file. I'm just going to say deleted message. Do as I say, not as I do, in terms of commit messages and so on and so forth. So we've gone and done that. Now in the version, now if we go to our files and our repository, that file no longer exists. We literally just need to go to history. And so that's where we deleted it. We just go to the previous version of that, and we can just go check out commit. And now it's back here, and we can see it there. There are a bunch of other other ways of dealing with this as well. So if we go back to here, you can, there's a bunch of other things where you can revert changes and commit. You can do a whole bunch of other things here that are a whole other story. But if you just want to see what you had written in, you can absolutely just revert, check out that commit, copy the changes elsewhere, and then use the XKCD solution of save changes elsewhere, copy them back in. It solves so many problems in practice and doesn't require you to know all of the ins and outs of Git. But there are definitely more sensible ways of dealing with this particular issue.
Fantastic. Thanks, Hannah. We've got 2 minutes, so I'll just get to one. There was one really important question. When you're working in a secure environment where you can't take anything out, is there a way to use GitHub so somehow? Okay,
yeah. So this is good. This is where
within the environment.
If you're working in a secure environment, it depends. If you wanted to do it, the easiest way to do it would be to, if you can export from that environment your codes, you could repeatedly annoy whoever's like in charge of the secure environment and ask them to download this version of the code, and then you'll be able to track all those changes outside of that environment. But yeah, if it's inside in a secure environment where they don't have Git installed for fairly obvious reasons, yeah, you can't use it in that particular setup. The way to do it would be to repeatedly ask for data exports of all of the files you've created.
Right. Yes.
Yep.
So the answer is difficult.
Yeah. Yeah.
Yes.
With that said, though, so there's a question from Daisy Evans here. I'm curious about how you manage data versioning when the data is subject to data transfer agreements, is sensitive and can only be saved in certain places. So in a setting of a non-secure environment, for example, where you can have the data in, for example, OneDrive, but you obviously don't want to put the data into the repository. One way of dealing with this, which is a fairly robust way of doing it, is have in OneDrive or whatever the accepted place you can store that data is, the data version, and have it named something. So what I will often do is I will have the data version named something like as follows. So data, then it'll be 2024 0319.csv which gives the date in terms of the 19th of the 3rd, 2024. And then if you had a new version in a couple of days' time, then you would name it something like, so in a couple of days' time, it would be to the 23rd. You just have multiple versions of the data sitting in whatever folder is acceptable for it to be stored in. And then in your sum code, place when one of the first things you have in your script, where you would load data from within the same directory that it all existed, just have it load from whatever the other directory is. Then every version of the data as it comes in, you have called something different. If you need to go back and revisit old versions of the data, you can do that. But yeah, it's a good halfway point between managing the fact that you don't want to be putting sensitive data into a GitHub repository while still allowing you to do proper version control.
Right. Okay, thanks, Hannah. And I hope we're actors saving the chat logs here so we can keep all the questions. So we need to wrap up now. Our session's probably going to time out in a moment. So let's please thank Hannah for a wonderfully informative session, and no excuses about no version control in the future from all of us, and brilliantly presented, Hannah. Thank you very much.
Thanks a lot.
Okay, so bye everybody.